You know, every data team has a ticking time bomb. And it's not buried in your warehouse. It's sitting right there in plain sight on your dashboards. Today, we're talking about the semantic layer. But not as some add-on BI feature. Nope. We're going to treat it for what it actually is. Critical production infrastructure that can either make or break the trust in your entire data platform. All right, let's dive in.
It always starts with this question, doesn't it? The one that makes your blood run cold. You get that Slack message from an exec with 2 screenshots. Hey, marketing's dashboard says our churn is 5%, but sales dashboard says it's 7%. Which one is right? And right there, in that moment, that's when the trust in your data starts to erode.
And look, this isn't just some abstract theoretical problem. This is a direct quote from Neil Gallagher, a data engineer over at iHeartMedia. This happened to them during a real BI tool evaluation. They suddenly realized that the consistency they had just taken for granted for years wasn't some happy accident. It was the direct result of a very specific architectural choice. We're going to use their experience as a guide to really unpack this.
And that brings us right to the core thesis for today. We as engineers have to stop thinking about the semantic layer as just another feature checkbox on a BI tool. We have to start architecting it with the same discipline we apply to our warehouse or our orchestration engine. Because that's what it is. It is production infrastructure.
So here's how we're going to break this all down. We've kind of hit on the 2 numbers problem. Next, we're going to reframe this with a powerful mental model, the API contract for data. Then we'll get into the real-world failure modes, compare the different ways you can implement this, give you a practical playbook to get started, and then wrap up with a framework to help you decide when you actually need one.
All right, I want you to completely reframe how you think about this. Forget about metrics and dashboards for a second. I want you to put on your software engineering hat. Because the single most powerful mental model for a semantic layer is to think of it as an API contract, but one that's built specifically for your data. So let's get a crisp technical definition on the table. A semantic layer is a metadata framework. Its whole job is to be a translation layer. It maps the messy, complex reality of your physical data tables, with all their weird column names and complicated joins, into clean, business-friendly ideas like net revenue or monthly active users. And what's really crucial here is that it doesn't store the data itself. It stores the logic. It's the official rulebook for how to calculate your metrics.
This API analogy isn't just a cute comparison. It holds up perfectly. In software engineering, you would never let your front-end apps query your production database directly, right? That would be absolute chaos. So you build a stable, versioned API to act as a contract, your client's code against that contract. Well, the semantic layer does the exact same thing for data. Your warehouse is the backend. The semantic layer is your stable API, and all your BI tools, notebooks, and data apps, those are your clients.
So architecturally, where does this thing actually live in the modern data stack? Well, it's its own distinct layer. It sits right between your transformation tools and your consumption tools. It takes those nice, clean tables that a tool like dbt produces and then exposes a logical, business-centric view of them to your BI layer.
And this is a super important distinction that trips a lot of people up. Your transformation layer, think dbt, is all about physical modeling. Its job is to take raw, messy data and produce clean, well-structured physical tables. Its job ends there. The semantic layer picks up where it leaves off and handles the logical modeling. It doesn't create any new tables, it just defines how to interpret the existing ones. What's a metric, what's a dimension, and critically, how do they relate to each other?
Okay, so the theory is great. But now let's get into the nitty-gritty engineering reality. What actually physically breaks in production when you don't have this layer? We're going to walk through 5 of the most common failure modes that lead to what I like to call an accidental spaghetti layer of business logic.
The first, and by far the most common failure, is metric drift. This thing is the silent killer of data trust. It happens slowly. Marketing defines an active user in their dashboard's SQL as anyone who logged in recently. Meanwhile, the product team defines it in their dashboard as anyone who used a core feature. Both definitions are totally valid in their own context, but now you've got 2 different numbers for the same core business KPI, and nobody knows which one is right. And this is exactly the conclusion the team at iHeartMedia came to. They realized the disagreements they were seeing between dashboards weren't visualization problems. The charts were fine. The root cause was much deeper. It was a failure of modeling, a failure of definitions, a failure of governance. These are all problems a semantic layer is specifically designed to solve.
When you centralize that definition, drift becomes impossible. There's only one source of truth for the logic.
All right, next up, join chaos. Specifically, let's talk about the dreaded fan-out problem. This is one of those subtle but absolutely devastating technical errors. An analyst wants to get total revenue, so they join an orders table to an order items table. But because of how that join works, the revenue from the orders table gets multiplied by the number of items on the order. Suddenly your numbers are massively inflated, and it's not always obvious just by looking at the query.
So just like that, one slightly incorrect join turns a $100 order into a $500 order in your report. Now multiply that mistake across thousands of orders. You could be reporting millions of dollars in phantom revenue. A proper semantic layer just prevents this. It has features like symmetric aggregates that understand the one-to-many relationship and will generate the correct SQL on the fly, making sure you get the right number every single time. And that brings us to another great practitioner moment from the iHeart team. They realized that for years, LookML had been invisibly protecting them from this exact problem. It wasn't just a nice feature, it was a critical guardrail that was enforcing the correct relationships between tables by design, preventing these fan-out errors from ever happening in the first place. And the failures just keep cascading from there. Number 3, you get duplicated business logic. That same gnarly case statement for defining a user status gets copied and pasted into a dozen different dashboards. Over time, they inevitably change and diverge. This leads directly to failure number 4, trust collapse. Leadership can't get a straight answer, so they just stop trusting the data, period. And finally, number 5, performance spikes. Every one of those slightly different unoptimized queries is hammering your warehouse, recalculating the same things over and over, and just driving your costs through the roof.
Okay, so I think we've established the why. The consequences here are pretty severe. So now let's switch gears and talk about the how, because there are several very different ways you can go about building one of these, and each comes with some pretty significant engineering trade-offs.
Let's just break down the landscape here. You've got your tightly coupled, thick semantic layers, like LookML. These give you the strongest governance and reusability, but you run the risk of vendor lock-in. Then you have the headless approaches, like the DBT semantic layer. The goal there is to give you strong governance but stay tool agnostic, though it can be a bit more complex to set up. And finally, you have the thin or do-it-yourself approaches, like using Superset's datasets or just creating SQL views. These are super fast to get started with, but as you can see, they offer the weakest governance and carry the highest risk of that metric drift we've been talking about.
This quote from the iHeart team just nails a critical lesson about total cost of ownership. The money they thought they were saving on software licenses didn't just disappear, it just shifted. It turned into a much more unpredictable and frankly more expensive cost, senior engineering time. They were now paying their engineers to manually do all the governance and review that their old tool had been automating for them.
So this can all feel like a pretty big project. Regardless of what tool you choose, how do you get started without trying to boil the ocean? Well, you need a set of minimum viable guardrails. Think of it as an actionable playbook for just getting a foundational layer of semantic governance in place.
Here is your starting playbook. And notice, this has nothing to do with buying a specific tool. This is about process. This is about engineering discipline. Agree on strict naming conventions. Create a wiki or a central doc with canonical definitions and clear owners. But here's the most important step. Treat your metric definitions like you treat your application code. Everything goes into Git. Every single change to a core metric has to go through a pull request and a code review. No exceptions.
But what if you're still a pretty small team? You might be thinking, is all of this just massive overkill for us right now? And you know what? That's a totally fair question. So let's look at a simple decision framework to help you figure out if the overhead of a formal semantic layer is actually justified for you right now.
Just use this as a quick checklist. Do you have more than, say, 3 people writing production SQL for analytics? Do you have more than 10 dashboards that leadership actually depends on? Are you trying to serve non-SQL users who need to self-serve? And here's a big one. Are your core metrics built on really complex business logic? If you answered yes to 2 or more of those, and especially if you've had that why don't these numbers match meeting in the last month, then yeah, it's probably time.
We have covered a ton of ground, so let's just distill everything down to the most important engineering takeaways. If you're a data platform owner or an engineering manager, these are the 4 things I want you to walk away with. Let's lock these in. 1, remember the mental model. It's an API contract, not just a BI feature. That clarifies everything. 2, it changes your maintenance cost from O and N down to O1. You stop fixing N different dashboards and you start fixing one single central definition. That's huge leverage for your team. 3, the future is probably headless. Decoupling your logic from your BI tool is a powerful strategic move. And finally, number 4, remember the spaghetti layer? If you don't proactively engineer a semantic layer, you will get one by default. It'll just be an accidental, tangled, unmaintainable mess. The choice is yours.
And that really leaves us with this final thought. The single most valuable asset any data team has is trust. It's not your warehouse. It's not your fancy dashboards. It's the business's fundamental trust in the numbers you provide. And the semantic layer, at its core, isn't about making pretty charts. It's your primary architectural defense for making sure the numbers in those charts are provably, consistently, and unarguably correct.